I'm a program manager on the speech and natural language team, and you probably have seen a lot of our stuff around. If you've ever used speech recognition from Microsoft, then that's what it is. If you've ever done spell checking, well, guess what? That's natural language. If you've ever done anything to do with grammars, that's natural language. So pretty much, we're the speech and natural language team. We do a bunch of things to do with language.
Okay.
My particular job is the program manager for the APIs to do with speech. So that's speech recognition and speech synthesis. So I think that answers the question.
First, let's just ask the tough question. How real is speech recognition today?
Speech recognition is really quite real. The thing to bear in mind is you've got to remember what the difference is between speech recognition and magic, right? And I can draw you a diagram of how that works.
Sure.
So if you think of, at the one end you've got, Robert Scoble here. See?
Looks right.
And he's uttering something. So you've got these sound waves, compressing out through the air there. And then, somewhere over here, there's some that there's the app does what he wants, right? And then there's this kind of void that occurs between here. And so there's a few things that happen. There's the speech recognition. So, let's say you said, "What's my itinerary?" Right? All we get is a bunch of numbers from the microphone, right? So go through that bunch of numbers and we do a bunch of really tricky stuff to figure out that you said, what is my itinerary? And then, we have to then go ahead and maybe attach some semantic values to that. So a good example of semantics is if you said, what's my itinerary on Thursday? So this is what we think you said, right? We're very good at taking what we think you said and turning that into text. So that's where we're very good. We're also very good at saying, oh, Thursday. Well, okay, Thursday would be, what's the 23rd today, right? So Thursday would be, say, that actually equals 5, 24th, 25th, 26th, 26th. So,
Hold on a second. I'm going to turn off my... the lens is freaking out, so I'm going to turn off the Steadicam. Yeah, sorry about that. I turned off the Steadicam feature.
That's okay. So my hand was just confusing you.
Yeah, it was...
I'm one of these people who has to talk with a whiteboard. My ancestors were probably the guys who drew on the walls in the caves. So, if we look at... We're pretty good at figuring out the semantics too. So you said, what's my itinerary? So, basically you're asking about your calendar or your schedule. And Thursday, we know the date. So, again, doing the mapping from some text to some actual semantic meaning, that's really good. I'm just looking at my notes.
So when the choice is constrained, the speech recognition gets a lot better.
Oh,
right?
when the choice is constrained, it's really very, very good. I'll talk about dictation too.
Right, like when as a developer, when you're expecting to hear June or July or a month, it's a lot more accurate than if I'm just speaking like I am to you right now.
Right. Although if you're speaking using words that are from a spoken language like we all do, again, it's pretty good.
Okay.
If you start using specialized terms that aren't used in everyday language, basically feeding into this recognition engine is you could think of it as it's like a database, which we call a language model. And so that feeds in there. So a language model could be the entire English language that's, 10,000 words that are commonly spoken by people and the probabilities of certain words occurring in certain sequences. And you can get pretty good, open dictation with that. However, if you're going to write an application and your application's all about, say, asking, what am I doing today? So for like a PDA type application, or if you imagine you could talk to Outlook or something like that, then you can really constrain the odds by saying, well, actually, we're just going to talk about this particular domain space today. And so you find a lot of speech applications that talk about a particular domain space because that means that they can do a whole lot more in terms of figuring out the semantics and translating that into actions. So,
your software runs the switchboard here, right?
Yeah, it does. It does. Let's try it.
That's sort of fun. Because
Let's try it. So,
Good afternoon. Who would you like to contact?
Robert Scoble.
Did you say Robin Little?
No.
Okay, please tell me the first and last name again.
Robert Scoble.
I think you want one of the following two people. Number 1, Robert Scoble.
That one.
Got it. Number 1, Robert Scoble. Calling the office.
All right, you can.
Oh, hang on.
All right.
I don't know if you've set it up, but we'll try. Call the cell.
No.
No, it's not mapped through, so your cell phone's not in the system. But otherwise, your cell phone would have started ringing there. And
Yeah, I already put my cell phone number out on my blogs.
Well, okay. Yeah, our system didn't read your blog. It's one of the few things in the world that doesn't. Right? So, you can see we're really good at this. Then it becomes, well, the next problem is actually a really hard problem because, it's a thing called intent. So intent is really easy to figure out where you've got a constrained system like this. But if you went back to the scenario you just spoke about, what if I'm just speaking openly about anything, right? The kind of, Star Trek engineer scenario, right? Then, we could be recognizing words out of the entire language, the entire, English language. And then figuring out intent based on that is really quite tricky.
Right.
So that's a much harder problem to solve. And, then, of course, once you've got intent, then it's up to the app to translate that into, the action. So, here you said, what's my itinerary on Thursday? And so the action might be the app might actually synthesize some speech saying, on Thursday you're doing so-and-so at 9 a.m. and what have you.
And your lookup engine has to have some grammar rules, too. Because
yeah.
2 or 2,
right.
how does a computer understand which one I meant?
Oh, totally. And then that's all in the language model. So there's a lot going on in here. There's a language model which says which words are used in which context and what have you.
Yeah.
But then there's this whole thing called normalization as well. So, if you were to take 526 and, look at that backwards, what if the person said 526? What does he actually mean? Does he mean May the 26th? Or does he mean the number 526?
Yeah.
Or what, right?
Or even worse, if it's 512,
right.
then do you mean May 5th, May 12th, or do you mean December 5th?
Right, exactly.
In some parts of the world, we say
right. So we can look at the locale and everything else. And there's other things like imagine you've got a social security number. 1, 2, 3, 4, 5, 6, 7, 8, 9. And us geeky types tend to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? But a lot of people out in the world will say 123, 45, 67, 89. It's still the same thing. So there's a whole lot of grammar and normalization, other sorts of problems that really have to come together. And that's what we're really good at, right? That's what we're really good at. And then it comes to this over here, translating it into intent. And if you can constrain the problem space you're working with, intent is a pretty easy constraint. If you have that open dictation scenario, then intent becomes there's probably a lot of patents pending around that or ideas to be thought of there. And then action again is pretty easy. Once you know what the person wants, you can execute on that. So,
right.
So what we try to do is we try to say, well, okay, we're good at this. We'll wrap an API around all of that so the developer doesn't have to worry about it. Okay? Because let's face it, how many developers actually... Developers are all about, the action, right? And the intent is usually the semantics of their particular application. Right? They don't want to have to deal with any of this. Why would you? So that's essentially what our API is doing for you. It's abstracting all of this away. So that's in a nutshell. I think your question was how real is speech, and I think it's very real. And I think you've got to understand where it fits into an application in order to make use of it, just like any other tool.
But even on our little phone demo, it took a couple tries sometimes.
Right, yeah, sometimes it does.
Actually,
take a couple of tries.
it's a bad demo because it's very accurate. I use it all the time.
Well, there's a few things going on there. Firstly, we've got the name of every single employee at Microsoft. So firstly, that's a big list of names. Secondly, there's a lot of people there who have names that aren't in the standard English, phonetic set, right? Yours isn't one of them, so I can't use that excuse, right? But these are the sorts of challenges you have with those large name databases. Names are really quite tricky to deal with. But if it was something else which was a much more constrained problem, or something for which we weren't dealing with a huge, broad phone set that we had to deal with there. Right. That would be a lot easier. But even then, you saw all I had to do was pronounce it again,
yep,
and it got you right.
Yep.
So it just misheard me the first time.
And actually, if you keep going, if it continues giving you a bad name, it'll eventually ask you, do you know their email address, or do you know their spelling of the name, and you can spell it out.
You can spell it out.
And then even if that's failed on me a couple times, and then you get an operator. So.
Right. But actually, there's a report on the Speech Server website that talks about this app, and it's in fact saved the company a lot of money.
Oh yeah.
Because it's all about increasing the call completion rate without actually having to involve a human being to answer the phone and proxy you through to the person you're looking for.
Yeah.
And so that's what it's done.
Plus, it works 24 hours a day.
Works 24 hours a day.
When we had humans, it only worked 7 a.m. until 6 p.m.
Exactly, and I've been using this for ages, long before it came live. And I use it for my cell phone. I use it all the time. So it works quite nicely. I'll show you something working on the desktop. So this is. Maybe if I bring this over here, can you zoom in on that at all?
Yeah.
Okay, so maybe I'll put it flat. I tied it up for you. Can you tell?
Oh, messy desktop here, yeah.
Yeah. Seriously, ask people. I tied it up. I made an effort for you. What you're looking at here is a markup language called XAML, and this is essentially a markup language for describing visual forms in Avalon, which is a new technology that's coming out with Longhorn. There's a release candidate of this that came out today, and the speech API is part of it. So I thought I'd show you what's going on here.
Excellent.
The stuff you just scanned over, you saw lots of things like combo box and combo box item and all the sorts of things you'd find on a form. So what I've done here is this is actually being enabled with the speech API. So I'll just put on my microphone. So I'll come down here and we'll run this. Expand destination. Select San Diego. Select business class. Select United. Check only non-stop flights. So I'll just take the microphone off. So you can see there, I can just say the names of fields and check items in them. It's a pretty simple demonstration of what you can do with speech recognition. Now, I'll show you the thing that's really impressive about this. If I exit out of this application, if you were to scroll through this XAML, you will find absolutely in no place do we actually mention the word speech. So this is totally a visual design.
You do have a speech manager.
Oh, there's a comment there saying this. The comment there says a single system.speech manager instance is automatically speech enabling this page. So the page is advertising the fact that we're using a cool API. So I'll show you that cool API.
Okay.
So this is the code behind that page, and the whole idea with XAML is that you can separate the design of the GUI from the code that runs it, and so that way your designers and your programmers can work somewhat independently, and you can change the visual design without actually having to affect the logic.
Yeah, we did a whole video with the XAML and the Avalon team.
Oh, cool. Yeah, we really dig this stuff. So here, this is the entire code behind. So all we've done is we've subclassed an Avalon navigation application, and all I did was I go ahead and I declared this object called Speech Manager, and it's in the system.speech namespace, and then I said, give me a new Speech Manager, and then I passed it a pointer to this navigation application.
Yeah.
And that's enough to tell it, hey, look, I want you to go and burrow through this application and look at all the XAML and figure out, what's the name of everything? When I say expand this, what do I do? When I say check this, what happens? And so, without having to have any knowledge of speech science whatsoever, I've been able to go ahead and basically opt this entire application, which was not designed as a speech application, but I've been able to opt it into to having a good speech UI. So that's one example. I've got a few others. This is the blog posting I did today. I'll do some free advertising for myself. So blogs.msdn.com/Robert Brown.
Okay. That's how I found out about you, actually.
Yeah. And it's called All the Cool Developers Use Speech APIs. You do want to be cool, don't you?
Yeah. All right. That's enough plugging.
So anyway, I put these examples up here because I thought they were pretty good. So we've built speech APIs before, and we have this COM API called SAPI.
Yeah.
And SAPI's got a couple of versions out there, and to do something in SAPI, to do a basic speech recognition scenario, would take tens or maybe even 100 lines of code to do it. So here I've done the same thing using this new managed speech API. So first thing I did was I said, well, I want my desktop recognizer. So I just go ahead and create a new one of those. And then I'll load a grammar into that recognizer. So a grammar is that language model we were talking about before. Yeah. So in this case, the idea is that you would build a grammar that defines the commands or the words and the phrases that you're looking for in your application. We've got an API to do that as well. Maybe I'll post about that in a couple of days.
Okay.
Then all you have to do is attach an event handler to it. So here I've just gone through and I've said, I've got a speech recognized event, and I've attached a delegate object with an enormous event handler here. So you could do something like write line or something like that. And we give you an object back called recognition result. It's got a property on it called result, and you just get the text out, and you can see whatever the person said that was within that grammar. There's also an array syntax in there, so you can pull out particular semantic values and what have you. But if you take a look at that, that's essentially, I formatted it nicely. So we'll call that maybe 4 lines on the screen to do what would have taken tens or hundreds in COM. Plus, you've got none of the COM pain to deal with, right?
This is really easy. I think I could even make some of this code.
Yeah, this.
Not to mention, I could steal it from your blog.
Yeah, steal it from my blog.
Now, this only works on desktop computers, laptops. It doesn't work on the smartphone yet, or a pocket PC.
The smartphone, we don't have the API on the smartphone, but we do have the engine. I don't have one of those phones with me today, but I do have the cup. My present to you, Robert Scoble, the Microsoft Voice Command Goblet. Take this and display with pride in your office. So what we've got there is, if you've got a Magneto-based phone,
this isn't Magneto.
This is not If you get that flashed up to Magneto,
okay.
You'll be able to sync up with your contacts list, or sync up with your Windows Media list, and you'll be able to say call. So and so, call Robert Brown, and it will phone me. So it's basically speech enabled your entire contacts list there. If you've got an older phone, if you've got say the Pocket PC phone, you can download Voice Command, which is the goblet I gave you.
Yeah.
The goblet doesn't recognize speech, but it does hold water, which is what phones don't do. So it's good at something. But it's basically similar sort of functionality. You can use that to play music by name on your device. You can use that to call people from your device. So all those sorts of things. So go to Handango, and shell out some money, however many dollars it is, and buy Voice Command. It's immensely popular up there.
Very cool.
It's very, very cool.
I was just getting at that the voice is going to be much more needed on devices that fit in your pocket.
Yeah, it'll be needed in your pocket, or even see this thing. This is tablet. So tablet actually has a speech recognition system in it, so you can use it. But the easier it is to use the API, you know, the fewer lines of code it takes to abstract all of this stuff I circled in red,
Yep.
The easier it will be for you to be able to build speech apps on here. And do you use a tablet mouse?
Oh yeah.
Yeah, I mean, these things are just absolutely awesome.
This one actually has 3 microphones in it.
Oh yeah, yeah.
So it actually it gives very good audio quality even without a headset, and makes it usable for a whole lot of things.
Yeah, I'm really thinking that now that we've got an easier API out there, we're going to see more and more use of the technology that's already in the system there. I'll show you another code sample.
Okay.
Because we like to talk about speech recognition because it's a nice hard problem and it's got all of these problems with semantics and what have you. But speech synthesis is also really interesting too. So here what I've done is I've said, let's say you want to do hello world.
Yeah. That's
pretty straightforward. So you just go ahead and you create yourself a new synthesizer. Right. And then you just tell it to speak hello world. That's not exactly rocket science, and it turns out the old SAPI API to do that was about that tricky as well. But
do you have an example of what that sounds like?
I don't have an example right here. I've got an example using some of the old voices.
Okay.
But just watch this space.
Okay.
Come back and talk to me in a while.
All right.
I guess the other thing to point out is there are lots and lots of speech synthesis voices out there. So we've got 3 that you can download for free from the SAPI website.
Right.
One of them comes in Windows, and then there's this huge ecosystem of speech synthesis voices out there. Lots and lots of third parties doing really nice voices.
And these are voices that'll read text to you.
Yeah, these read text to you. So this is the opposite problem.
Yeah.
But this is what
Are the voices getting better? Because they used to sound really robotic.
The voices are getting...
You are listening to it.
Yeah, the voices are getting way better. Basically, it's a change in technology. So, okay, I'm going to draw you another diagram here. So, in the old days, the way you would synthesize a word is, you would take a word like hello, and you'd break those up into the phonemes, and then you might say that the h sound, it's got this kind of signal when you look at it through a signal analysis, and then you'd say, well, okay, how would I, take various waveforms and approximate them to that? So I, basically say, well, that's one waveform, then I'll maybe add this other one in and subtract this other guy. And basically, you build a digital signal processor to do this, and that's the old style voice that you're used to listening to. So basically, what you would do is you'd take a bunch of recordings of people saying the various phonemes, and then you'd figure out a DSP solution, and then you could synthesize pretty much anything just by adding waves together, which is pretty cool. The way people do it these days is quite a bit different. So what we do is rather than having a list of signals to be combined, what's maintained is a database of samples. And so you build a large database of samples by recording in controlled conditions, right? So you have very controlled conditions where people are reading scripts that you've given them, and then you feed that through the software to isolate the phonemes and what have you. And then it really boils down to building software that's smart enough to pick up the right samples and splice them together so that it sounds natural, right? And that's where it becomes tricky, because it's very easy to write a database lookup, but you still got to splice it all together so that it sounds nice, right? So if you look at the Microsoft Research website and do a search for speech synthesis there, you'll come up with some interesting stuff.
Okay. We'll link to that on this interview. So I'm getting a hint that in the future that the computer can talk to you with a much more natural sounding voice.
I think speech just gets better. I think that's all there is to it. It'll recognize what you say even better, and it'll speak to you even better.
Right. What are you hoping developers do with the APIs that you showed?
Well, there's a few different areas. The most obvious area that people use speech for is accessibility type solutions. So, people who need assistance to read the screen or need assistance to input. So speak.
Well, that's sort of why I want it on a smartphone, because
exactly
keying on this little pad is not exactly a productive endeavor.
Let me show you This is as complicated as I want my telephone to ever be, right? Yeah. These guys did their research. They figured my thumb could hit 2 buttons. Yeah. 2 buttons, right? The phone is a real accessibility issue for me. But even accessibility on the desktop. But there's more to it than that. There's a lot of vertical spaces where speech actually makes a whole lot more sense. So, for example, if you think of people working in warehouses, or people working with machinery, or people doing inspections, or even caseworkers meeting people and working with people, these are all scenarios which really don't lend themselves to sitting down in front of a keyboard. Right? They all lend themselves to, you're busy doing other things with your hands or your eyes. Maybe you're making eye contact with the person you're working with, right? And to keep drawing your attention away from that to work on a keyboard is really unproductive. I mean, if you were to look at any kind of work that involves people moving stuff around with their hands, and you said, well, okay, I'm going to take that away from them. They're going to not use their hands, because their hands are going to be busy typing into an application. And so you might have built some great productivity application, but it's counterproductive, right? Because these people, they do their work based on how they use their hands. There's also other things, obviously, automotive, or any time you're mobile, you want to be using your eyes to see where you're going, and your hands and feet to
So your technology is used in the new car PCs, right? Because we've had those on Channel 9 too.
Right, we have some stuff in there. It's not just ours. There's some other people in there too. But in fact, that's got our old SAPI API in there. So that's our COM API. There's also a lot of enthusiasts as well. So we get contacted by people all the time who just have some idea for some new type of product. Right, these are products that you can't build without speech. And so it's always, we have these discussions under non-disclosure, but it's interesting that people will say, well, okay, I've got this idea. How do I use your API, your technology to build this application? And maybe some of these ideas will be the next big thing. We just don't know. Yeah. There's a lot of stuff happening out there.
How soon will it be before I can take video that's digitized and on my computer, like a Channel 9 video, and tell it to spit out a text file from that video, and have it somewhat accurate, where voice 1 says, check out our new speech API, and voice 2 asks, where do I get it?
Right, I understand, yeah. We don't have an out-of-the-box solution for that, but conceptually, if you were to build an application to do that, the first thing you have to do is you need to train the recognition engine to whatever the speaker's voice is like. And the way to train it is that speaker needs to be reading a transcript, or you need to provide a transcript. Okay. And that's the state of the technology these days. You can do it without that. We could just take that and feed that into our recognizer, but if you really wanted to maximize accuracy, you'd need to train it. So if you're thinking of taking this video of you interview a different person each week and take that back, I think it's going to be reasonably difficult for you to do that. Yeah. But if it was people interviewing you each week, we could build a language model for you and just feed that through, and that'd have a much better likelihood of success, because there's so many variables in there. There's also the acoustics of the room and the microphone and all sorts of other things that contribute to, even if it just contributes 1%, right? That's one extra word in 100 that you need to go and correct. Or, it's going to come up with some hypothesis, and that word may in fact look just fine in that position. You may not even know it was an error. So, but yeah, it's all feasible. It's all just time and software, right?
Well, thanks for anything else that you wanted to show us today?
Oh, look, I could go on forever, but you should probably come back in a few months, and we'll show you some more cool stuff.
I bet it's a word that starts with an L. Longhorn.
Yeah. Yeah.
So, good. Thank you very much, and we'll come back and see how speech looks in future versions of Windows soon.
My pleasure. Thanks for coming around.
Thanks.